Hey guys, today we're going to learn about inequalities and specifically section 2.1, which is just reviewing what inequalities are, the different symbols, and how to graph them. So for the first three problems, let's get set up with a couple different signs first. So we have these signs on the bottom. The first one is a greater than or equal to sign. The second one is a less than or equal to. The third one is just less than. And the fourth one is greater than. They're going to be solved the same way as we solve equations in the next video that I make for this, but they are very different from having an equal sign in between. So just keep that in mind when we solve these. So let's go through these problems. They want us to use less than, greater than, or equal to compare. So starting with with number 1, 4, question mark 4. Well, 4 is equal to 4, so we would use that symbol there. And the second one, 7 is bigger, so it's greater than negative 2. And then the third one, negative 5, is less than positive 4, smaller than 4. When we graph, something you're going to want to keep in mind and write down, when you graph the specific point on a number line, you're going to want to use a shaded in circle anytime there is a line underneath, meaning it's less than or equal to or greater than or equal to. So that's the point. It's going to be a shaded in dot. It means that that value is included in the solution. When you have a less than or greater than sign, no equal to, we use an open circle that's not shaded in. Think more ink here, more ink inside your circle. Less ink here, no ink inside your circles. So this problem says write an inequality for each statement. Then sketch the graph of the numbers that make each inequality true. So the first statement says the temperature, T, in Sweden is at least negative 10 degrees Celsius. So key things, the variable T, the words is at least, and the number negative 10. So at least means it's either negative 10 or greater than that temperature. So negative 9, negative 8, 0, 1, 2, 3, 4. Those are all greater than negative 10. So we start with the variable T, and we think of which symbol applies. So at least would be greater than, or it could be equal to negative 10. So remember, when we graph and it's less than or equal to or greater than or equal to, we use a shaded in dot on that number. And then we decide what direction. Well, think of this as a thermometer, just horizontal. It has to be at least 10 degrees, so it could be 10 degrees or more. And then I put an arrow at the end saying it goes on forever. Although with temperature, we know it can't reach super, super high temperatures. You might also see the answer written as this. They have a circle, and then they put the line right above, which is fine too. Whatever makes it clear and neat for us to read and help you with, and for yourself to look over your notes. Okay, part B. The elevation E of Alabama is at most 2,407 feet. You should pause the video and try it. Is at most is important here. The elevation E, which is the variable we're using, and the number again. So always start with the variable, so E in this case. Decide what the words is at most means. So is at most. That means it cannot go over that. The most it can be is 2,407 feet. So it can be E less than, or it could be equal to 2,407 feet. So I put my point around, estimate where 2,407 is, so maybe around here. This would be a shaded in circle again, and it can't go above, so it can't go to the right. So we're going to shade to the left, and make sure you have your arrow. Now we're going to go backwards. It says write an inequality for each graph. Then, in words, describe all the values of x that make each inequality true. So we'll describe it in words. So part A, we have a point at 1, and we're looking at all numbers greater than or equal to 1. Equal to because this point is shaded in. So start with a variable, which is x in this case. So for this first one, I'm going to zoom out a little bit. X would be greater than or it's equal to 1. I'm going to describe in words underneath. These are all real numbers, bigger than, greater than, or equal to 1. I'm going to skip down to D. You guys can try B and C on your own for extra practice, but I'm going to skip down to D. We have a point on 1. It's an open circle, and we're looking at numbers that are smaller than 1. So we use the variable x, and because 1 is not included, it's an open circle, we use the symbol less than, not equal to, in the number 1. So in words, this is all real numbers less than 1. And I would even specifically put not including 1. So when we look at that, we can think of numbers like 0.99999 as a solution, but 1 would not be a solution. Okay? We'll try a couple of these. This says write each sentence as an inequality. In part A, you have a number, W, minus, keyword is minus 35, is less than or equal to negative 2. So let's translate this into words. W minus 3.5. So that would, that would just simply be the variable W, a number, minus 3.5 is less than. So is less than or equal to, what symbol is that? Well, that's this symbol right here. So less than or equal to negative 2. We'll learn how to solve these in the next lesson. So right now we're just going to leave it there. We're not going to solve for W. In part B, 3 is less than a number n plus 5. So translate it again. 3 is less than, so just this symbol, a number n plus 5. And that's it. C, 0 is greater than or equal to twice a number x plus 1. So 0 is greater than, but it can also be equal to twice a number x, so 2 times x is 2x plus 1. Just to show you one of these, how you would solve them, just like in an equation, you want to get the variable isolated. So in this case, we would subtract 1. Negative 1 is greater than or equal to 2x. And the last step here would be to divide by 2 on both sides. The 2's would cancel, and you would have x. I'm going to write the variable on the left. This is where you're going to have to be careful in the future when we solve these. Less than or equal, this says negative 1 is greater than or equal to x right now, or negative 1/2 is greater than or equal to x. See how the tail of the symbol is pointing to the x? When you rewrite it, keep the tail pointing to the x. And then the number on the right, negative 1/2. And then you would graph these, which again, we'll do in the next video. Okay, this says tell whether negative 4 is a solution to each inequality. So in order to tell if a value is a solution to an inequality or even an equation, you would have to plug that value in for the variable. So if you want to set it up as a box instead of x, you can plug the number in. Plus 8 is less than negative 3. In that box, we plug in negative 4 to test it. So what's negative 4 plus 8? Negative 4 plus 8 is 4. Then bring down the symbol. It's less than negative 3. To tell whether it's a solution, you ask yourself if the statement is true or false. Is 4 less than -3? No way. A positive number is not less than a negative number. So we're going to say that no, -4 is not a solution. In the next problem, we have -4.5x is greater than -21. Again, you want to plug -4 in for x and find out. So -4 times 4.5 is going to be +18, greater than -21. And then you ask yourself, is the statement true? Is 18 greater than -21? No, it is not again. So no, -4 is not a solution. Tell whether -6 is a solution to the inequalities. So pause the video, try these on your own, and then we'll go through them. Okay. In the first one, you end up with -2 is less than -1. This is a true statement, so yes, it is a solution. In number 4, 10 is less than or equal to 3 minus, be careful here, put the -6 in parentheses, because now when you simplify, it's really 3 plus 6. So is 10 less than or equal to 9? Nope, it is not in this case, so no, it's not a solution. 5, 21 divided by x is greater than or equal to -3.5. So 21 divided by -6 is greater than or equal to -3.5. So in your calculators, go ahead and plug that in if you haven't tried it yet. You will end up with -3.5 is greater than or equal to -3.5. So -3.5 is not greater than, but this symbol is greater than or equal to, and they are equal. So this statement is true. Even though it's not greater, it still follows the equal to. So this is a true statement, so yes, it's a solution. Last one. 4 times -6 minus 25 is greater than -2. This is -24 minus 25 is greater than -2. We end up with -49 is greater than -2. A huge negative is not bigger than a smaller negative, so this is a false statement, so no, it's not a solution. All right, so for these problems, we're going to graph each inequality. So we always want to plot the number that's given first, or if we end up solving for it and we get that value, you plot that number. You want to pick a number to the right and to the left. So -3, to the right of that would be -2, and to the left of this would be -4. Okay, so then you plot a point on the value they're talking about, so y is less than or equal to -3. So that is a shaded in circle because it's less than or equal to. And then think, numbers less than -3. That is being, ooh, I went the wrong way. That is all values to the left of -3. Okay, next problem. 2 is less than x. Do me a favor, and anytime you see the number to the left, switch it so the variable is to the left. So I'm going to rewrite this as x. Think of this as an alligator sign eating the x, so I want to make sure it's still eating the x. And then put the 2 on the right. So x is greater than 2. Plot the number 2, a number to the right, a number to the left. A point in an open circle goes on 2 because it's not an equal to symbol. And greater than would be all values to the right. Number 3, x is greater than 0. A point goes on 0. We put a open circle again on 0 and shade everything to the right.